Okay. All right, let's keep going then. Nope. Click the wrong thing. Here it comes. There we go. All right. All right. So now what we saw was a savings annuity. That's what we actually saw. So again, that's where you're taking money out of your paycheck, making monthly deposits into the account. You're making monthly deposits, it's compounding. We saw that just now. But now what we want to do is consider what's called a payout annuity. So here you could think of it as, instead of putting money into the account regularly, we're taking money out regularly. Or if you want, you can think of it this way. With the savings annuity, that's before retirement. As it says here, payout annuity is after retirement. It's when retirement occurs. You're taking money out regularly from your retirement account. I mean, there is money in there, and that money in the account is still earning interest, not the money you take out, but the money that's in there. And of course, after some time, this account will be empty. Okay, it's essentially the money you're going to live on when you retire, when you're not able to work anymore. Okay, if you choose to retire. Okay, that's what a payout annuity is. Okay, now I could go through a calculation to show how it works. That's what I did with the savings annuity. It's very similar though. So let me just get right to the formula. Instead of making monthly payments, essentially you're making monthly withdrawals, but the balance isn't starting at zero. It's starting out at some high number. And this is our formula that's going to govern what's happening. The underlying formula, so to say. Notice it is a little bit different, right? For instance, here we have negative NT. We have 1 minus this. P sub 0, right? That's the balance in the account at the very beginning, when you first start retirement. PMT here is monthly withdrawals. You're taking out each month. You're making regular withdrawals here. Just like before we made regular, deposits. Here, we're making regular withdrawals. Okay. R is our APR, our annual interest rate, as a decimal. And N, again, is the number of compounding periods in a year. T is time, so it's how many years you're doing this for. All right. Now, again, we have this. If compounding frequency is not stated explicitly, again, this is really more what the book is doing, the convention. But basically what's going to end up happening is how often it's compounded is the same as how often we take withdrawals. The frequency is the same, in other words. I mean, again, I want to say you don't have to do that realistically, but for this chapter, that's what we're doing. Okay, so we have these different formulas. There's actually another one for loans, and we won't get to it today. So how do you know when to use which one? This one, the payout annuity, is when you have many withdrawals. Annuity here is really the same as savings annuity. That's when you have many deposits. Here, we're going to have many withdrawals. Okay, so that's good. Let's do an example. And actually, before the exam, I should say this. We will be able to use our TVM solver, as you'll see. All right. So let's suppose that we have $500,000, okay, in our account when we retire. Let's just assume that, okay? We have $500,000. And let's say we want to be able to take out withdrawals from the account for 40 years. Okay, again, it's all hypothetical. Let's assume the retirement account is earning earning 6%. So that's our APR. So how much can we withdraw each year? Now notice it says each year, not monthly. It's each year. So P0 is our starting balance, right? That's $500,000. PMT is our monthly withdrawals. So that's unknown. R here is 0.06. That's our APR. Excuse me. No, our APR, that's right, as a decimal. I'm wondering if it says APR, and it says right there. N is 1, because again, we're taking out one withdrawal each year. So it's going to be compounded once per year, and it's 40 years. So here's our formula. All I did here was I took the parameters and I plugged them in. And now we want to know what PMT is, right? So we have to solve for that. And just like in the other class, what I did was I showed them like what you have to do, calculation that is. You know, you want to get PMT all alone, kind of like solving for X when you have an equation. So you're going to multiply both sides by 0.06 divided by 1. That's a 6. I don't know. It's hard to write with this mouse, but you multiply both sides by that. Right? This is going to be gone because they cancel. Then you divide by this big numerator, both sides, and you end up with this. Now, it's good to put the unknown on the left side. That's what I did. And then we have to calculate this. Now, you could use Microsoft Excel if you really wanted to. You could. I mean, you don't have to, though, but you could. Okay? If you need help with that, don't be afraid to ask me. Okay. Okay. But when you do that calculation, this is what you end up with. Just remember, when you do this in your calculator, you want to use more than 2 decimal places. So I would use as many as you can and do the top and bottom individually. Just remember your order of operations. That's very important. Okay. So this is what we get. $33,230.77. That's per year, so that's pretty good. Okay. So that's by the formula. Okay, are there any questions about this? Yeah, I can't see the chat, so if you have a question, use that hand raise feature or just speak into your mic. Okay. Okay. All right, so let's keep going. And now I just said before, we could use that TVM solver to solve these questions, to solve these problems. We can do that. That's what I'm going to do now. It's the same problem as before, but we're going to use the TVM solver. So remember, our PV is the initial balance. Now, it's negative, though, because, again, you could think of it as being in the account. We're not collecting it at once. I mean, even if you made it positive, you would, well, I'll show you what would happen. But when we make that as negative, I guess you could think of it also as like an outflow because money went into the account. PMT is unknown, okay? Because, that's what we want to know. It's the same problem as before. FV is 0 because, again, after some time, there's going to be nothing left in the account. We keep doing, so that's what's going to happen. I is 6%, right? Again, remember, for I, it's the APR, but you don't convert it to a decimal. You leave it as a percent. Capital N is little n times t, which is 1 times 40. Okay, let me get to that. Let me get to the TVM solver. Gotta stop this. There it is. Can you see it? Here, yep, there it is. Let me clear it. Okay, so again, we have, here we go. So we said capital N was 1 times 40, so that's 40. Capital I was 6%. Good. PV is negative 500,000. PMT we want to know. FV is still 0. Now, P-Y and C-Y, those are each 1 because we're assuming there's only one withdrawal each year. Okay? Right? C/Y is the number of compounding periods per year, right? And these two are always going to be equal to each other. So we solve for PMT. That's what we want. Click that. We get, oh, sorry, my fault. In PV, it should have been 500,000. Not just 500. So we solve for that, and what the heck? Try taking this as 0. Try this now. There we go. $33,230.70. I think that's what we got before. Yep, that is. So that's what we got before, though. Notice here it's positive, and that's good because remember, money is coming to us. You know, it's a, what do you call it? It's a cash inflow, I think. It's positive, meaning it's coming to us directly. Let's say without thinking I made this positive. What would happen then? Just this. It would just be negative. That's the only difference. Hold on. But again, you know that when you write something down, like on a test or something, in this context, the answer, it doesn't make sense to say negative, you know, in the test or something. So you know that it should be 33,000. So that's all. Not to mention the negative would tell you that the money's going away from you, but we know money is coming to us because we're withdrawing it. So, you know, it's just something to consider. Just something to keep in mind. Okay. Right, good. Okay, so that's what we get here. Okay, let me just pause the recording.